Graphical behavior of polynomials at x-intercepts. If a polynomial contains a factor of the form x minus h to the power of p, the behavior near the x-intercept h is determined by the power of p. We say that x equals h is a 0 of multiplicity p. The graph of the polynomial function will touch the x-axis at zeros with even multiplicities. The graph will cross the x-axis at zeros with odd multiplicities. Sum of the multiplicities is the degree of the polynomial function. Now, if we're given a graph of a polynomial function of degree n, we want to identify the zeros and their multiplicities. If the graph crosses the x-axis and appears almost linear at the intercept, it is a single zero. If the graph touches the x-axis and bounces off of the x-axis, it is a 0 with even multiplicity. If the graph crosses the x-axis at a 0, it is a 0 with odd multiplicity, and the sum of the multiplicities is n. For example number 6, we want to identify the zeros and their multiplicities. We're going to use the graph of the function of degree 6 in figure 9 to identify the zeros of the function at their possible multiplicities. So first, let's identify the zeros of the function, or we call them x-intercepts. So here we have an x-intercept located at -3. We have another one here at -1, and then we have another one here at +4. Okay, so if we look at the first x-intercept, okay, what's happening is that it's bouncing off that x-intercept at -3. Okay, if we take a look at the next intercept at -1, it's going through that x-intercept. So here we can see it's going through the x-intercept. Okay, and then at the x-intercept of 4, we can see that it's going through like a cubic motion and it flattens out at the intercept. So let's take a look at this in words. So the polynomial function is of degree 6. So the sum of the multiplicities must be 6, because we're told that the polynomial function is of degree 6. Now, starting from the left, we notice that the first 0 occurs at x equals -3. So the graph touches the x-axis, so the multiplicity of the 0 must be even. The 0 of -3 most likely has multiplicity of 2 because it bounces off. Okay, and it's not as flat here at the value of -3. Now, the next 0 occurs at x is equal to -1. And the graph almost looks linear at this point because it's going through the point there. And this is a single 0 of multiplicity of 1. And then the last 0, which is 4, okay, we can see the graph crosses the x-axis, so the multiplicity of 0 must be odd, so we know it's going to be odd, but we know that the multiplicity is likely 3, and that the sum of the multiplicities is likely 6. And finally, let's go ahead and count. So if this is a multiplicity of 2, this is 1, 2. Multiplicity of 1, that's 3. Multiplicity of 3 plus 3 gives you 6.